Assalamu alaikum everyone. Let's start lecture 18 for CS116 object oriented programming. In last lecture we discussed a relatively complicated concept of decorators. We learned what actually decorators are, how you can code a decorator, or how you can code a user defined decorator, and then how you can use that decorator. A decorator could be a user defined decorator or it could be a built-in decorator. And in today's session we'll use a couple of decorators to implement some other functionality in Python. So as we discussed in the last session towards the end, that we have three types of variables in a class: instance variable, class variables, and local variables. Similarly, we have three types of methods in a class as well. And up till now, the kind of methods that we had been using were instance methods. But we can define two more types of methods, which are static methods and class methods. And this is the topic of our today's session. So we'll see these with examples, and then we'll do some more comprehensive examples to wrap up whatever we have studied so far. So as I told you, there are three types of methods that can be defined in a class. Instance method, we are familiar with these methods. Actually, we are familiar with this only kind. And then we can have class methods and static methods. So I'll talk about each one of them turn by turn, and then we'll see some coding examples. Let's first discuss instance methods. Although we have been using this since the very beginning, but right now I'll recap some points which will help us differentiate these methods from the other two types, class methods and static methods. So what are instance methods? We call these instance method using an instance of a class. By instance of a class, I mean object of a class. So first you define an object, and then through that object you call such methods using that dot operator. Okay, I'll come back to this point later. These methods, they take this essential argument self as their first argument. Actually, self is a symbolic name. You can use any name here. The point here is that the first argument is considered as this self argument, and what happens when you run the program, this self is replaced by that instance or that object that on which you are invoking this method. So that means each object or each instance will run a different copy of these instance methods, right? So each instance will have a private copy, so that's why they are associated with an instance. They can manipulate all kinds of attributes, in fact class attributes as well as instance attributes. So you can increment or decrement any class attributes. Actually, we mostly use class attributes as counters, so you can do that, and you can manipulate any instance attribute as well within these methods. Now they are called bound methods because each copy is bound to a specific instance, right? They are not free methods. Like, you see, the functions that you define in a regular program, not the methods, the functions, they are unbound entities because they are not bound to any object or any code. Any function or any code can use them freely, but these instance methods, they are used with specific instances, so that's why they are called bound methods. Okay, within a class you can access an instance method from other methods. You just have to use that self operator, self dot method name, and you can access that method. And outside the class, that means from main program or from any other class, again you can access these methods using instance variables. You cannot, actually the point here is you cannot call these instance methods using class names. They can only be accessed using instance variable. Inside a class, they are used with self dot operator, and outside the class you have to define or instantiate an object first, and then using that object you can call these methods. Now let's come to the second type, class methods. Class methods, they are not bounded to any specific instance. These class methods and the static methods, they are basically instanceless methods, because we do not use instance to access them. By instance I mean an instantiated object, that is called an instance. So we do not use any object to access them, and they can be accessed using class name. I'll show that to you later. But we do not require, an object to access them. So they are called instanceless methods. Okay, in class methods, we provide one special argument, the same way as we do that in instance methods. Here, we provide that first argument, and traditionally we call it CLS. Just like self, you can name it anything, but the point here is that the first argument in any class method will be treated in a special manner. So, what class methods expect? They expect that a class name has been passed as first argument. So when you will call these methods using a class name, that class name will be passed in place of this CLS. This is similar to instance method, but the difference is there we use self, and self is replaced by the instance, and here CLS will be replaced by the class, right? Another way of explaining this could be, you see the difference between instance variable and class variable. You access instance variable using self dot operator, whereas you access class variables using class name. So the same difference lies here. You access instance variable using self dot operator, and you access class methods using class name. Okay, so they are accessed via class names. And like class variables, these are basically there to manipulate those pieces of information that are common for all instances. We actually rarely use such methods. We rarely need to define class methods. But if you need to define one, then that means that you are working on class variables within these methods. You have to perform some operations on class methods, and for that purpose, since class methods, they remain same across all the objects, so those operations you will perform in some class method. Okay. Now this is one something that is different from instance variable, sorry, instance methods. Instance method, they can work on class variables as well as instance variable, whereas class methods, they cannot access instance variable, because in order to access instance variable you require that self or instance of an object. But since these methods, they are not considering first argument as instance, it is considering first argument as a class name, so it won't be able to access any instance variable. So you cannot use or manipulate or print or access any instance variable within a class method, right? Okay, here comes the show how you specify that a specific method is a class method. You actually put this class method decorator on top of that method. So at the rate class method is a decorator, is a special decorator or a built-in decorator that converts the method following it into a class method, right? Now you know what a decorator is. So this decorator will simply add some functionality to your class method that will make it a class method actually, right? So I'll show you how we can use this. Okay, how these methods, they are accessed within the class and outside the class. You see, you can access these methods both ways. You can use class names to access them, or you can use instance if available. Then you can access these methods using instances also. But you see, as I said, that these methods, they are same across all the objects. So there is not much sense in accessing them using instance variables. So usually we use them to access, we use them through class names mostly, right? And the last point, I would again emphasize that such methods, they are rarely used. We rarely need to work on class variables. As I told you earlier as well, that mostly we use class variables to keep count of objects. That's the most common use of class variables. So that count can be incremented in initiator, easily. So we rarely require these kinds of methods in a class. Now, these are the third type of methods. These are called static methods, and they are also instanceless methods in the sense that they are not tied to any instance or an object of a class. Previously in Python 2, they used to call them unbound method. Unfortunately or fortunately, I don't know, in Python 3 they do not have this term defined, unbound methods. But in a sense you can say that static methods are unbound because they are not bound to any instance of a class. Okay, the thing which is different about these instance methods is that they do not require any special argument as their first argument in the argument list. Like if you recall, in instance method we provide self as a special argument, special first argument, and in class methods we provide CLS as a special argument in the argument list. But these methods, they do not require any self or CLS arguments. All the arguments, they are just regular arguments uh, of a method or of a function, because they are almost like functions. Now, what's their utility? Why we use them? Actually, they are used for performing certain tasks um, which will help an instance method to organize its code. For example, you are writing an instance method and it's a very long method and you are performing certain tasks again and again. Let's suppose you want to find average of certain values and you have to perform this average function again and again. So what you can do, you can make a separate method and you can call that within your instance method again and again. But the point here is that average method or average calculation method does not directly relate to the functionality of your class. So you do not have to make it an instance method because you think that the user of your class will never use that method, will never require that method, or it is not directly related to the functionality of my class. Although I'm using it in certain cases, but it does not relate to my class, apparently. So what you can do, you can make a static method. That static method, that can be called by the instance method or a class method whenever needed. But uh, you don't have to show that at the interface. Like, the user of your class does not need to know that there is such method. So usually we define such methods for housekeeping tasks, um, and or you can say for performing some utility functions or some common actions. Okay. They can also, class methods, they can also only work on class attributes. They cannot manipulate instance attributes, because you see, we are not passing any self argument to these methods. So that means they cannot access any of those instance attributes. So they work only on class attributes or any local attributes that they define within themselves. This is the decorator for defining static method. So if you want to make a method static, you can use this @static method decorator on top of your static method. And I have written here optional. Why I'm calling it optional, I'm going to tell that shortly. Now let's see how you can access it from within a class and outside the class. From within a class and outside the class, you can access them using class names. Just like class methods, you just have to use complete class name dot, and then you can call any static method. But if you are defining a static method using that static method decorator, then you can access that method through an instance variable also from the main program, right? So there I wrote optional. That means that if you are not using that decorator, that is absolutely fine. You can define a static method, and whenever you want to access that static method, you can use class name dot operator with it, right? Now, if you are using this decorator, static method decorator, what difference will it make? From inside the class, it will not make any difference. Inside the class, you have to call this static method using class name. You cannot call it or access it using self operator. But from the main program, if you are using that @static method decorator, you can, from main program, you can call it through class name as well as through instance variable. So that's the only difference that you get if you define a static method using that specific decorator or without using that decorator. So My point here is that since these are for housekeeping functions only, for internal usage only, so you do not you rarely access them. In fact, I think you never access them through instance variable from outside the class. So you can easily omit this add static method decorator while defining static method. Now let me show you example for all these three types of methods that we have seen so far. Okay, in this example, I'll define an instance attribute and a class attribute, and then I'll define each type of those methods: class method, instance method, and static method. And I'll try to show you what is the difference between these three types of methods. So this is my class. I'm calling it my class. Here I'm defining a class attribute. The name of this class attribute is class attribute, and I'm initializing it to a string class attribute so that I can see it by printing it. So that's why I'm initializing it to this string. Okay, now this initiator, I'm using this initiator just to initiate an instance attribute. So here's my instance attribute. I'm calling it instance attribute, and I'm again initializing it to a string instance attribute. So this is an instance variable because I'm accessing it using that self dot operator. So as soon as you create that object, this instance attribute will be created in the namespace of that object. Now here's my first method. This is an instance method. Uh, we have been using such methods throughout, so there is nothing new about it. I'm just showing you that how it can easily access both types of attributes, class attributes as well as instance attribute. So here I'm trying to print class attribute from within this method. There is no issue in it. This will print the value of that class attribute on the output. Then I'm trying to access an instance attribute. The difference between the two is that you always access class attribute using class name and instance attribute using self. So both are okay. They'll print the respective values on screen. And then I'm printing another statement that shows that we are inside this instance method. So there is nothing difficult here. Now let's define a class method. We know that we require this decorator, class method decorator, if you want to declare a method as class method, because it's the only way you can differentiate a regular method from a class method. So here's my definition, and I'm passing that argument CLS. And as I told you, this doesn't matter what name you use here. So again, I would emphasize that decorator is the only way by which you can differentiate between a class method and an instance method. Now since you are putting the decorator over this method, that means that this CLS will be expected to be a class name, right? And if you don't put that at the rate class method decorator, then this CLS would be expected as an instance, right? So here I'm trying to access the class attribute. Obviously I'll access it using class name. CLS holds the class name, so this is absolutely fine. This will print class attribute on screen. Here I'm trying to access instance attribute using self. Now the problem here is we do not have this self value inside this method, so I cannot do this. So this statement will generate error. This means that you are not allowed to access any instance attribute from within a class method. Similarly, if you try to access this instance attribute using CLS operator, then also it will give error, because CLS is a class name, and if you are using class name dot operator, that means it will expect instance attribute to be defined outside all the methods or right after your class definition, and that's not the case. Instance attribute is initialized in the initiator, so this will again generate error. So that means you cannot access this instance attribute in any way. Okay, this is another statement just to distinguish it from the other two methods on output. So this is our class method. Now let's come to the third method, the static method. I'm using this decorator, and then I'll define my static method. Now you see, I don't need this decorator to differentiate my static method from a class method or an instance method. Why? Because I'm not putting that essential argument there. So that means that this is not a class method or an instance method. So add static method is an optional statement. You can put it there. You, if you don't want to put it, you have that choice. And the only difference this statement will make, that it will allow you to call this static method using an instance from outside the class. So here again, I am trying to access class attribute. This is absolutely fine. You can use class name and you can access any class attribute. But if you try to access any instance attribute using self, that is not possible, because you are not passing self here. So this is not recognizable. So this will cause error. Similarly, CLS is also not recognizable here. So this will also cause error. And this is an absolutely fine statement which I am printing in this method. Now I'm defining one extra method. I hope you are able to guess which kind of method it is. It is actually an instance method, because I'm using that self as first argument. Now this method is here just to show you that how can we access any kind of method from within another method in the same class. So this another method is just trying to call all those three methods. So for instance method, you have to access it using this self dot operator. Otherwise, it will give you error. For class method, you call it using class name, and static method, that is also called using class name. Although you can call these class methods and static methods using self also, but that doesn't make sense much here, because usually these methods, they are general methods that remain same for all the classes. They are not instance dependent, or you can say they are instance free. So it doesn't matter how you call them. You can call them using class name, you can call them using self, but it's better to call them using class name. But for instance method, you do not have any alternate choice. You always call them using self dot operator. So I just showed you that how you can access these three types of method from within the class, and how you can access different types of variable from these three types of methods. So now let me show you how they are accessed from the main program. So let me instantiate an object called A of class my class, or you can say A is of my class type. And we know how to call an instance method. You simply use this a dot operator and call this instance method. Now if you try to call this instance method using class name, this statement will produce error. So that means that you cannot call an instance method from within a class or from outside the class using class name. You have to use that self argument or an instance of a class in order to access it, right? Now let's come to the second type, the class methods. You can access that class method using class name. You can access this using the same terminology from within the class and from outside the class. And you can even access it using instance name from outside the class and also from within the class. But as I told you, that this doesn't make sense, because these methods are usually common for all instances. So it's better to call them using class names. That will be less confusing. Now about static methods, you can call them using class names from within the class, from within the class and from outside the class. At both places you can use this class name to access them. And you can also access static methods from outside the class using instance, but this is only possible if you are using that static method decorator above your static method. So this is the difference that decorator creates. If you are using it there, then you can, this last statement is error free. It will be executed normally. But if you are not defining a static method using that static method decorator, then this statement will give you error. So but that's not important, because we know that these static methods, they are basically there for some housekeeping task. So you rarely call them from the main program. So it doesn't matter that you use that static method decorator or not. So in most cases, it doesn't matter. Now, I'm not showing you output for this code because this is pretty simple. This code is there in the file. You can just run it and see what it prints at the output screen. Now let's do a comprehensive practice problem which will help you revise all the concepts that we have studied this week, like operator overloading, static methods, maybe decorators. So let's see that. So the example that I'm considering here is this fraction class. Um, we have already created a fraction class. We'll extend that class for more functionality here. And apart from this, many of you might be thinking that this class already exists as a built-in class. Like you can, include this module and you can manipulate fractions using that. That is absolutely true. Such a module exists, but this class is a really good example for understanding. So we can overload a lot of operators here. It's easy to understand because you guys have been working with fractions, since school. So this is going to be a good example to clarify many things. So this is the class that I plan to make here. The name of my class will be fraction. It will have two instance attributes, numerator and denominator, like before. We'll define an initiator method that will initialize these two instance variables, and then set numerator, set denominators. These will be the setters as before. So we'll go through this common code quickly. Then str method to display my fraction in some specific format, and then convert decimal will convert this decimal to convert this fraction to an equivalent decimal value. And the last three methods are the new ones that we'll be adding right now. Add, which will overload the plus operator, gt, which will overload the greater than operator, and the last one is I add, which will overload the addition assignment operator. Okay, so first let's practice this overloading, then I'll show you an example of static method in the same class. Okay, like I said that I'll skim through the these simpler functions quickly because we have seen them before also, I think in lecture 8 or 9. Okay, this is the class definition. I'm calling it fraction. This is my initiator method. It will initialize numerator to 0 by default and denominator to 1 by default, because denominator cannot be 0. That will raise a divide by 0 error. So whatever user passes will be assigned to this instance variable numerator. Same is the case with denominator. Then we define the setter functions. This setter function is simple. And if you can recall, we put a check here in denominator's setter function. And that was that user cannot pass a 0 value. So if the user passes a 0 value, then this error will be printed. Otherwise, whatever user passes, that we can assign to denominator. For str method, first I have to decide that how I want my object to be printed. Let's suppose that I want my object to be printed like a real fraction. Like let's suppose if the fraction is 1 upon 2, I want it to be printed as 1/2. So this is the simple string that will be printed, numerator, then slash, and then denominator. Or you can choose whatever way you feel like when you print this object fraction. Then convert decimal. This is really simple. I just have to divide numerator by denominator, and that is going to be a float value that will be printed on screen. If you want, you can, uh, put a round function around this to round that value off to 2 decimal places or 3 decimal places or whatever you want. Now, the next method that we have to implement is this add dunder. Now, this method will overload plus operator. So what it will do, it will actually add two fractions. So we'll invoke this method on a fraction, and another fraction will be passed to this method as a parameter, which is f2, which will be f2 in this case, and then this method will add those two fractions. Now before coming to implementation of this method, let's revise how you add two fractions. Okay, now let's add two fractions. Let's suppose 1 upon 2 is one fraction and the other fraction is 1 upon 3. Now just think about it from programming point of view. We have to create a formula that we can put there in that function. So what we do when we add two fractions, we first make the denominator same. So the easiest way to make the denominator same is that I multiply this first fraction with the denominator of the second, which is 3, right? And I multiply this second fraction with the denominator of the first, which is this, right? So that will make the denominator same, and then we can simply add the numerators, and that will give us the required answer. So if you see what formula I have made here, you numerator of the first, it will be multiplied by denominator of the second, plus numerator of the second multiplied by denominator of first. This sum will form the numerator for our answer. And in denominator, what we'll have the two denominators multiplied by each other. So this is the formula that I'm going to put over there. Similarly, we'll later implement that function of comparison, greater than. For greater than also, we use the same logic. We first equate the denominators, and after equating the denominators, you just compare the numerator. So for comparison purpose, we can compare, how you equate the denominators by multiplying by the other denominator. So in comparison, I can say 3 multiplied by 1. That means numerator of first multiplied by denominator of second. This will be compared against numerator of second multiplied by denominator of first. You see, I'm taking these two values because in this case denominators are equal. So that means I'll just consider the numerators and then I'll compare them using this greater than logic. So these are the formulas that we are going to implement for overloading add operator and for overloading greater than operator. Okay, now let's put that logic over here. Okay, now if I use that formula here, then that would mean that I want or I expect f2 to be a fraction. So one more thing I'll add here in this code, which we have not done before. I'll put a check here to see if the user is actually passing a fraction to this operator. Like uh, f2 should be a fraction. It cannot be any other object type. So for that check, I'm using that is instance function that I told you about a couple of lectures back. Here it is. So I'm comparing this f2 with this class fraction. So this function will return true if f2 is of fraction type. So if this is true, then only I'll add the fractions. And this is my formula that we had derived previously on that Jamboard. Numerator of f1 self is representing f1. So numerator of f1 multiplied by denominator of f2, then that slash is just a continuation operator, plus numerator of f2 multiplied by denominator of f1. So this will form my numerator. So this is the first value that will be returned, that will be placed in the numerator of the final sum, comma, then I have my denominator, and denominator is simply the product of two denominators. So this is the value that my function will return. But if this is instance method returns false, actually is instance is a function, if it returns false, then in that case I'll print an error message. So here it is. So we have implemented that logic, and we have also put a check here to see if user passes a fraction element, or sorry, a fraction object to this operator. Now let's implement or overload the other operator of greater than. Here also I'm using that same check of is instance, and if is instance returns true, I'll compare these two fractions. Now in that case, I only have to compare the numerators. So this is the logic that we made. Here that backslash sign is only used as a continuation operator. So what I'm doing here, I'm comparing the product of f1's numerator and f2's denominator with the product of f2's numerators, f2's numerator and f1's denominator. So this is the required comparison, and if this function is instance returns false, in that case I'll print this error message, right? Now let's quickly run some test code. Here I am defining fraction 1 upon 2 as f1, and f2 has been defined to 1 upon 8. Now let's call this f1 plus f2. uh, if you recall from last slide what this function was returning, it was returning a numerator comma a denominator, that means two values. So here we'll get a tuple, so it will print a tuple at the output, and here it is. Now the problem with this tuple, the only problem with this tuple is this is a correct answer, but the problem is that this is not a simplified one. So we'll come to that shortly. For now this is correct. 1 upon 2 and 1 upon 8 plus 1 upon 8 without simplification gives 10 upon 16. And if I compare them, then this gives true because 1 upon 2 is greater than 1 upon 8. So up till now we have overloaded two operators, the plus operator and greater than operator. We were supposed to overload one more operator, that assignment operator plus equal to. So I am leaving that work for you. You will implement this uh, operator, and you will test this using this test code, right? So it's pretty easy. You just have to figure out how you want your output to be, or what this function will return that can be assigned to that value f1, or that fraction f1. So you will just have to change that add dunder a little. Let's implement one more method for this class fraction. We just saw in on the last slide that there was a problem with addition. Actually it was not a problem, but the output that it was producing was a correct fraction, but it was not a simplified fraction. So let's implement another method that will simplify a fraction. So first we'll have to develop or think about the logic which we'll use to simplify a fraction, and then we'll come back here and implement it in Python. Okay, let's decide on some logic for simplifying fractions. Let's suppose this is my fraction. So this was the result of that last output. So how can you simplify this fraction? You basically cancel out numerator and denominator with some common factor. And you know the best way to cancel these out is using the highest common factor of 10 and 18. So here you see the highest common factor of 10 and 18 is 2. So if you cancel out by 2, sorry, it will be 5, and 9. So this is 5 upon 9. Right? So this is the simplest possible fraction in this case. Similarly, if you are cancelling out, let's suppose 4 upon 8. So you can start by cancelling out using 2, but the best way is to use the highest common factor of 4 and 8. So highest common factor means a value that can divide both, and it is the highest value for both these numbers. So in this case 4 is that value. 4 can divide 4 and 4 can also divide 8, and it is the highest common factor for both. So if I cancel them out using 4, so this will give me the simplest possible fraction in one step, right? So that means our main task will be to find highest common factor for numerator and denominator, right? So how are we going to do that? What we can do, if you can recall from last course, we once derived a function that can find that was printing actually all the factors for a number. For example, if I pass 4 to that number, so it will print a list of all the factors of 4. So 1, 2, 4. And if I pass 8 to the same function, it will print list of all the factors of 8. 1, 2, 4 and 8. So we can use that function, we can implement that function, and then we can call that function for each of them. So what change will we make here? Instead of printing these factors on the screen, we'll make it put these factors in a list, right? So if I call that function separately for these two numbers 4 and 8, I'll get these two lists. Then I'll have to compare these two lists and to find the highest common factor. So for that, I can implement a logic that I start scanning one of the list, let's suppose this first list, from the highest value. I choose the highest value first and I look into the second list if it's there. So if it's there, then that means that's the highest common factor, which in this case is 4 is the highest common factor. But if that highest number is not found in the other list, then I'll go to the other value and then I'll search it into the other list. And I can use simple operator of in for this, like 2 in this list, 4 in this list, that will return true or false, and I'll know the highest common factor. So that means what I'll do here, uh, I'll divide numerator and denominator both with highest common factors of these two, I mean numerator and denominator. And in order to find highest common factor, first I'll uh, use a method to generate a list of all the factors, and then I'll compare those two lists to get the highest common factor. So that means it's a multi-layer process. So let's implement this in Python. So let's start implementing this method simplify. Uh, Here, let's first decide that how we want this method to work. What I want here is that I'll call this method on a fraction type object, let's suppose f1, and then what it will do, it will simply simplify that fraction f1, and that's all. It will not return any value, it will just simplify that object that has invoked this particular method simplify. Then later we can print that object to see the simplified result. So it will actually change that object, that self object. So self is here the fraction which we want to simplify. So according to the logic that we discussed on Jamboard, this is what I want. I'll first find HCF of numerator and denominator. So here what I am doing, I am trying to call a method find HCF, and this find HCF method will take two arguments, numerator and denominator, basically two integers, and then it will simply return me the highest common factor for these two. Now you see this method find HCF is a housekeeping kind of method, because we won't like to call it from outside because it is not directly related to the concept of fraction. So but it is required for some internal calculations. I don't want to put all the code here in this method simplify, otherwise it will become too much occluded. So what I want to do here is I want to modularize it, I want to divide it into smaller functions, and this find HCF is that first function or method. Now here the best way to define this method is to make it a static method, because this is going to be one of those functions which will be required by the inner implementation only. It won't be accessed from the outside. So considering that it should be a static method, I'm using this class name fraction dot along with it, because later I'll define it as a static method. So I'll define this method later. So here it will return me the HCF of these two values, numerator and denominator. And then what I have to do, I only have to divide numerator of self with this HCF, and I have to convert it to integer, otherwise it will print answer dot zero. And same case for denominator. So this is the simplification technique. Now what we have to do next, we have to provide implementation for this find HCF method. Now let's write code for that second method find HCF. This is a static method. I am not using that self keyword, uh, but we know that first element, it can be treated as a self. So that will be the case only if I access it as along with a dot operator later in the code. So I am not going to access a dot anything, so it will not be treated as self. Or if you are still confused about it, you can always put that static method decorator over this method. So what I'll do in this method, I'll first call this another method find factors, as we had decided in that discussion on Jamboard. This method find factors will return a list of all the factors for a, right? And I'll save that list in factors a, factor underscore a, and I'll get a similar list for b, like factor underscore b will contain a list of all the factors of b. And then what I have to do, I have to find a common factor among these two lists, factor underscore a and factor underscore b. So here what I'm doing, I'm scanning factor a list backwards. So this range function, I'm not explaining it here. You should be able to make out what's happening here. I'm starting from the highest index and moving towards the lowest index. So let's suppose if the list contains 1 2 4, this in this loop I will acquire values backwards, first 4, then 2, then 1. So whatever I acquires, I'll simply search that in the other list using this in operator, and if it's there in the list, then I simply have to return this factor. Okay, so that means as soon as I find that value, I'll return it, and that's it. And if I don't find that value, then we know that every factor list starts with 1, so ultimately I'll get a 1 if there is no common factor between those two values a and b. And here's the last method. This method also has to be a static method, as we saw on last slide that I was accessing this using that class name. So, or you can use that static decorator over it. So find factors is simple. We have already implemented this logic in last semester too. I'm initializing an empty list. I'm checking all the values of x starting from 1 and see if the remainder is 0. So if remainder is 0, then that means that's a factor. I'll append that to my this factors list. And after coming out of this loop, I'll simply return this factors list. So I hope this is a pretty understandable code. And what we saw here, that we made two static methods. So here is some test code. This is a fraction. I'm calling this method simplify. And this method simplify will simply simplify f1 and doing nothing. It does not return anything. So then I'll print f1 to see if I get the correct answer. So here it is. So what we did in today's lecture, we saw these three types of methods: instance methods that that are there to manipulate instance attributes, then class methods that are there to manipulate class attributes, and then we can define some static methods also if for some common functionality or housekeeping functions for a class. So in the end, we did an example which helped us revise the concept of overloading operators as well as use of these static methods. That's all for today's lecture. Thank you.